All right, so this lesson will finish up what we're going to do with solving oblique triangles. So we looked at law of sines, and we saw that law of sines is used in 3 different cases. Can somebody give me one of the cases that we use law of sines for? Like the S's and A's? Yep, Alex?
Side angle side.
Yep, side. No, side angle side is not one of them, sorry.
Side angle.
Side angle is one. Yep. Okay, what's another case we use law of sines, Rudy? Angle side angle. And there's one more. Does anyone remember the last one? Yep.
Side angle angle.
Yep, side angle angle. So those 3, you use law of sines. Well, let's look at this one. All right, so we have A is 2, B is 3, gamma is 60. I'm not going to do anything with solving this problem right now. I just want you to look at it. Let's make a sketch and see what kind of triangle this one is. All right, so A, alpha, B, beta, C, gamma. Again, not to scale. What kind of triangle is that one? Naming with the 3 letters that, S's and A's. Yep. It's side angle side, SAS. Was that one of the 3 that we listed for law of sines? No. So because it's not one of those 3, you can't use the law of sines. Well, let's look at what happens if you try to use it. Do you have a row in this table that has everything in it? No. So if you try to set up the law of sines, let's say you pick the first 2 rows. You'd have sine of alpha, which you don't know, over A, equals sine of beta, which you don't know, over B. The problem is you just set up a proportion with 2 things you don't know. You can't do that. It can only be one thing. So if you say, all right, I'll pick 2 different rows. I'll use the last 2. Well, sine of beta, you don't know, over 3, equals sine of gamma over C, which you don't know. So again, you run into the problem with 2 things you don't know. And the same thing happens if you pick the first row and the third row. You're still going to have 2 things you don't know. So you can't solve that triangle with what we learned before. What you can use to solve it is the law of cosines. So the law of cosines is used to solve 2 types of triangles. Side angle side and side side side. And I've drawn one of each type so you can see what they are. There is one more combination of letters you could put together, which I didn't mention at all, which would be angle, angle, angle. Does anybody know why I didn't mention that type, either with law of sines or law of cosines? Yep.
Because if you don't have one side, you can't tell how long any of them are, because
Right.
B is big or small.
Yeah. Like, let's say I just said to you, I want you to think of a triangle with the angles 60, 60, and 60. That's an equilateral triangle. And I said to you, okay, those are the angles, 60, 60, 60. How big are the sides? Well, it could be anything. They could be like a sides 2, 2, and 2, or 10, 10, and 10. If all you know is the angles, it's not enough information. Okay, you have to have at least one side in every single problem we're doing. Sometimes you'll have 2 sides, sometimes you'll even have all 3. No matter what, you've got to have an S at least once. So when I describe to you the law of cosines, I'm going to use the same notation as before. A, B, and C will be sides. Alpha, beta, and gamma will be angles. Now, I'm going to show you part of it, and I think you'll see a similarity to something. And this similarity is actually how you would prove this law. Okay, we're not going to go through the proof of law of cosines because It involves something called trig identities, and we haven't learned those yet. So we can't really prove this at this point. But I think if I just show you the first part of it, you'll have an idea of what formula this is based on. So anyone have a guess what the law of cosines comes from? Yeah?
Pythagorean theorem.
Yeah, it has to do with the Pythagorean theorem. But with the Pythagorean theorem, you can only use it if you have a 90-degree angle. So obviously that just can't be the formula. It's going to be something a little more to it. And what there is that on the end. Okay, it's kind of an adjustment for not having a 90-degree angle. Right? So basically the way it works in general is one side squared equals the sum of the other two squared. It doesn't just have to be a and b. Okay, we're gonna write it different ways. Okay, but one side squared equals the sum of the other two minus twice the other two we just had right there times the cosine of the angle across from the side you started with. So if you start with a c, it would be a gamma. If you started with an a, you'd have an alpha at the end. If you started with a b, you'd have a beta at the end. Okay, but that's the pattern. All right, so let's see if we can write it for starting with b squared. Okay. Anyone think they could tell me what would come next? B squared equals what squared plus what squared? Peter?
B squared equals a squared plus c squared
Yep.
minus 2ac cosine beta.
Yeah. So one side squared equals the sum of the other two squared minus twice the product of the other two times the cosine of the angle across from the side you started with. And these are all the law of cosines. It's just different ways to write it. Okay. Honestly, I don't remember the different ways. I just remember in my head, one side squared equals the sum of the other two squared, and so on. I just remember it that way. And then you can call the sides whatever you want. X, Y, Z, A, B, C. Because if we wanted to write this for all the different labels you could use for sides, I mean, there's an infinite amount of ways to write this. You might call your sides D, E, and F. Then you'd have three other ways you'd have to write it. Right? So it's better if you can just remember the general idea, but I'll show it to you one more time. Okay, anyone think they can give me the last version? Yeah.
A squared equals b squared plus c squared minus 2bc and then cosine alpha.
Yeah. So one side squared equals the sum of the other two squared minus twice the other two cosine of the angle across from the side you started with. Now let's look at let's just look at the top one for a second. Let's pretend that you tried to use this formula when that angle was 90 degrees. Okay, let's see what would happen. So if you tried to use this on a right triangle. So let's fill in a 90 for gamma and take the cosine of it. Just start with that. So cosine of 90. I get 0. What's 0 times anything? 0. So what would happen if you use this on a right triangle? It would work, but this would be 0 times that. It would cancel it out, and you'd end up with minus 0. So basically this whole part would just disappear, and you just would be left with the Pythagorean theorem. Okay? So that's why when you learn the Pythagorean theorem, you don't need this part on the end, because it's 0. Now, gamma is not 90, so this part will not be 0. Any questions on that? All right, so which version you use? Well, if you have side, 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 you can use any version you want. Okay. Think about if you knew A, and you knew B, and you knew C. You would know everything in every formula right up to that line. You'd be able to fill in everything. If you had a side angle side problem, then you have to use the version for whatever angle they give you. Okay? Because in side angle side, you're already missing a side. You're either going to be missing the A, the B, or the C. So you're going to be missing something in the first section. You can't be missing anything else. So if you're already missing a side, you better know the angle. Okay? Because you can't be missing two things in the same equation. All right, so let's try. I think that's the original problem I had put up to start with. All right, so first thing I would do is determine should I be using law of sines or cosines. We've already done that. This is a law of cosines problem. Okay, if we call these version 1, 2, and 3, what version of the law of cosines do I have to use here? Or if you don't think I have to use one and I have a choice, I could use any of them, you could tell me that too. Alex?
The only angle you know is gamma, so you have to use the first one.
I have to use the first one. Okay, I'm already missing C. So that's going to be an unknown. Nothing else that comes after it can be unknown. You can only have one unknown per equation. So you've got to use the one that has gamma. Okay. So let's fill it in and see what we get. So we get C squared equals, and now just plug in everything. A squared, so that's 2 squared, plus 3 squared. And some of this in future problems I'm going to start to do in my head, but for the first one I'll write everything out, every single step. So then we have 2 times A times B times the cosine of 60. Right. So let's start to simplify some of that. Eric, what's 2 squared?
4.
4. And 3 squared? 9. Minus, Paige, what's 2 times 2?
4.
And times 3? 12. Yeah. 12 cosine 60. So I did a little bit of simplifying, but you still want to finish what's in the parentheses first. Okay, so let's do 12 times the cosine of 60. Okay, let's see what we get for that. 12 cosine 60 gives me 6. So the cosine of 60 is a half. And half of 12, that's how I got 6. All right. So we get 4 plus 9. Connor, what's that going to give me? 13. Minus 6. 13 minus 6 is going to give me 7. And I'm pretty much done, except I don't quite have C yet. I have C squared. So how do I get rid of, that's a function, right? Squaring something is a function. So we need another function that cancels it out.
The square root.
The square root function. So C is the square root of 7. And for these problems, we're always going to round off. Okay? So let's just take the square root of 7. And we get 2.646. Okay, even if we use this 2.646 for another calculation, you went to 3 places, so it should, that's pretty accurate for what we're going to do. Okay. Any question on how to find C? Okay, so let's put that in our table. And let's sketch the triangle now that we have that extra piece of information and see what else it is. We knew it was side angle side, but now it's more because you know other things. Right, so we had A, alpha, B, beta, C, and gamma. So it started out as side angle side. Does anybody see what other type it is now? Yep.
Side, side, side.
Yep, it's side, 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 because we know all the sides. And if we look at it as a side, side, side problem, that still falls under law of cosines. Does anybody see what other type it is? And let me, actually, you know what? Let me fill this in. Because that was given. Yep.
Side angle side.
So side angle side, yeah, that was the first type. So that one we knew right off the bat. But something else with that angle, it is another type. Yep.
Side, side angle.
Yeah. Side, side, angle. It's one way to look at it. Or side, side, angle. Looking at it the other way. Now, if we were to look at this as a side, side angle problem, what law would we use? We would use the law of sines. But I'm not going to do it that way. Does anyone know why I want to avoid using the law of sines here? Especially for side, side angle. Well, what happens with the side, side angle case?
We're gonna have to,
Right.
answers.
You could have the two solution, the one solution. We got to go through all that stuff. If we just use the law of cosines again, it will automatically give us the one correct answer. Because there is only one answer to this problem. Okay. Side, side angle, we'd have to figure out which one of the two answers is correct. Okay, so I want to avoid having to worry about that. So we'll do law of sines, cosines one more time. Okay. Any question on why we're going to do law of cosines again and avoid law of sines? Okay. If you want to do law of sines, go ahead. But you're going to have to be very careful that you put down the right solution. Because remember, it's going to give you two. And one of them might be right, one of them might be wrong. And it's kind of tricky to figure out. So just stick with law of cosines. All right. So that was to find C. And now we can pick alpha or beta. It doesn't matter which one we pick. So Mason, you want to do alpha or beta?
Beta.
Beta. All right, so let's find beta. And do you remember how the law of cosines starts out and has the beta at the end? Okay, let's write that down. B squared. So I get, and I'm going to kind of do this as I go. Is everyone okay with that? Okay. So B squared is 9. Yep. And can you keep going? D squared equals?
Equals A squared
Plus?
plus C squared.
Okay, let's stop there for a second. A squared plus C squared. Well, A squared is 4. And C squared, well, I have it right there from the last step of the work. C squared is 7. Okay. So don't take 2.646 and square it. You're going to get like 6.999 or something. C squared equaled 7. We just had that up above. All right, so A squared equals B squared plus C squared minus, can you keep going for me?
2 times A times C.
2 times A times C. So I'm just going to write that. 2 times 2 times, and C is 2.646. Yep. And what's the last thing?
Cosine beta.
Cosine beta. right, I'm going to put in, well, I was going to put parentheses. I just don't want to confuse people between multiplication and a decimal point. So that's multiplication. That's my decimal. All right, let's start to simplify. Emily, 4 and 7 gives me
11. 10, sorry. No, yeah, 11.
Yeah, you're right, 11. So 11. Now it's okay to do that first because it's outside the parentheses. It's not going to affect anything that happens inside the parentheses. So it's okay to do your addition first in that part. Now the next part is 2 times 2 is 4. And I need 4 times 2.646. Okay, I know it's rounded, but it's the best we can really do. And we got 3 decimals, so it's still pretty good. 10.584. Whether or not you put parentheses around this, or you don't put parentheses, doesn't change anything at this point. All right. Anybody tell me what I would do next here? You guess, yep.
10.584 times cosine of beta.
All right, if we knew what beta was, we could do 10.584 times the cosine of beta. But I don't know what beta is. So there's nothing I can do with that part. It's a good guess. Any other thought, Mom?
Would you do 11 minus 584?
All right, 11 minus 10.584. Let me rewrite this equation a little differently, and then I'll ask you the same question. So it's 9 equals 11 minus 10 times something you don't know. Would you do 11 minus 10 there? No. Okay. This part at the end, think of it as just a letter. It's cosine beta. It's something you don't know. So what would you do if you were trying to get x by itself in this equation? You would minus the 11. Yep. You're going to take the 11 and put it on the other side. Okay. So that's our next step. Minus 11, minus 11. So 11's gone. 9 minus 11 gives me negative 2. Okay, so that's better. We moved one thing over. Now we have to deal with that negative 10. Okay, how would we put the negative 10 on the other side? Yep.
Divide.
You would divide by it. So divide each side by negative 10.584. Here, the negatives cancel. Okay, and let me write down what we have now. 2 divided by 10.584 equals cosine beta. Okay, we've run into this before. We want to get rid of the trig function. So how am I going to get rid of cosine? Inverse cosine. Yep. Don't do inverse sine on accident. Okay, that's if you have sine. We have cosine, use inverse cosine. Cosine and inverse cosine, those functions cancel out, just like square and square root. Same idea. And that's your answer for beta. Inverse cosine of 2 divided by 10.584. Okay, don't actually write down what 2 divided by 10.584 is. Okay, don't round this off anymore. Just type the whole thing in at once. Okay, so I'm going to do inverse cosine of 2 divided by 10.584. Okay, and I get 79.108. Now, that's rounded. So, I mean, it could be 0.109, it could be 0.106. But the point is, if you put 0.10 something, you're going to be pretty close. If you put 79.3, like if you were that far off, something's wrong. Right? So you should have 79.10 something. In my case, I'm going to round to 108. Okay. Any questions on that one? Right, now, since we already used something we had to calculate to find beta, if I have C wrong, well, I already have beta wrong too. Okay, there's no way around that. So what I'm going to do now to find alpha, I'm just going to add the two together and subtract from 180. Okay, if you have extra time, you could find alpha the same way we found beta, okay, and double check. But what I'm going to do is I'll just subtract from 180. Okay, so 180 minus gamma gives me 120. And then I'm going to minus 79.108. So if you were to go through and find alpha the same way we just found beta, you should get 40.892. Maybe you'll get 893, 895, it might be a little different, but it should be 89 something. Okay. Any questions on that one? Okay, so that's a typical side angle side problem. And what's nice about side angle side, kind of from showing you an example, is it combines both types of things that can happen. The type where the variable is already by itself on the left, and all you're doing through the whole problem is arithmetic. And the other part of it, the variable was on the right, and it's more like solving an equation. Okay, so to find beta, that's more like solving an equation. Finding C, you just had to do arithmetic. Okay. Most people make a mistake with solving the equation. Okay. They forget, like, oh, I should subtract the 11, and they usually try to do 11 minus 10. And you can't do that. Okay, so any questions on that one? Okay, so that's side angle side. Let's try one side side side. Okay, then we'll do a word problem, and that'll be it. Okay, this one is probably the easiest case to tell what it is right off the bat. If you look at the table, you have a side, and a side. Side, side, side. Okay, so it's not law of cosines. It's not law of sines. It's law of cosines. Now, which version of the law of cosines would I have to use first? Yep.
Any of them.
Any of them. It doesn't matter. You know A, B, and C. So you know everything in every formula right up to that line. Right? So you can use any version you want, but how many times are you going to have to do this at a minimum? You have to do it twice. Optional, you could do it a third time, or once you do it twice, just take the two angles, add them up, and subtract from 180. Okay? The other nice thing about this type of problem is if you do it 3 times, you can find alpha, beta, and gamma all separate from each other. So that means you could make a mistake on alpha and still get the other 2 right. Because all you're going to do for each problem is go back to what was given. You're not using what you're calculating to find other things. Unless at the end you want to try the shortcut and just add the 2 you have and subtract from 180. But keep in mind, if you made a mistake, then you're going to carry that mistake through. Okay. All right, so let's pick one of the 3 angles to find first. Matt, which one you want to find first? Alpha. Okay, so let's find alpha. Can you tell me how the law of cosine starts out that has alpha in it?
Doesn't matter if I'm right.
Well, you said the one with alpha, right? So there's only one.
Oh yeah, a squared equals b squared plus c squared.
All right, stop there. So a squared equals b squared plus c squared. A squared, b squared, plus c squared. Got it? Okay.
Minus 2bc.
All right, let's do that. 2bc. 2 times b means 2 times 3, which is 6, times c, 36. So 2bc, yep,
Times cosine alpha.
times cosine alpha. Right. So because I did a couple steps as he was saying it in my head, I can really shorten how much I have to write. Okay. Katie, can you tell me what I can simplify on the right-hand side? Yep, we can add 9 and 36. And it gives us 45. Macy, can you tell me my next step?
Subtract 45.
Yep, we're going to subtract 45. You cannot do 45 minus 36 because the 36 is multiplied by a variable, cosine alpha. All right, so we got 16 minus 45 is negative 29. Okay, Orion, what would be my next step?
Divide by 30, or negative 36.
Yep, divide by negative 36. Negatives on the right are gone, 36 is gone, negatives on the left are gone. So I would have 29 over 36 equals cosine alpha, but what am I going to have to do at the end, Ryan, to get rid of cosine?
Take the inverse of cosine.
Yep, I'm going to take the inverse cosine and type that in. So really, you can shorten this up. So we really shortened it to like basically four steps. Okay, let's see what happens. Okay, whenever you do this kind of problem, just quickly check and make sure the number in the denominator is bigger. Because if the number in the numerator is bigger, don't even bother typing it in. It's going to give you an error. So something's wrong. Okay, so the number in the denominator should always be bigger. All right, so we got second inverse cosine. 29 over 36. And there's our first angle, 36.336. Okay, now we'll do it one more time. Doesn't matter if we do beta or gamma, because we're not going to use the 36 to do anything else. We're going to forget about it. So, Rudy, you want to do beta or gamma?
Beta.
Beta. Okay. Let's find beta. And can you remind me how that starts out again?
Starts out with b squared, so 3 squared.
All right, so b squared, yep, equals,
Equals 4 squared plus 6 squared.
all right, so 3 squared, let me write this down, equals 4 squared plus, what did you say after that?
6 squared.
6 squared. So that's 16 plus 36. If you even want to do that step in your head and add that, you can too. Okay. But sometimes the more steps you do in your head, the more mistakes you make. All right, so we got that, minus what comes next?
2 AC.
2AC. So 2 times 4 is 8 times 6. 48, yep. Times the cosine of what angle are we finding? Beta. All right, so I'll add 16 and 36. Connor, what's that going to give me when I add those up?
52.
52. And Faith, can I do 52 minus 48? No, what do I have to do with the 52?
Subtract it.
Subtract it. So I'm going to do 9 minus 52. I get negative 43. And at the same time, I'm going to divide by the negative 48. Okay, because I know I'm going to have to divide by it in the next step. So I just did it right away. Okay, and Robin, my last step to get beta by itself?
Do an inverse cosine.
Yep. You can type it in as negative 43 over negative 48, or if you just want to cancel them, that less you have to type in. And that's beta. Does anybody have what that comes out to already? Is that
26.384.
26.384? Okay, so now if you have a little extra time, the way I would recommend is do gamma the same way we just did. If you're kind of running out of time and you don't think you're going to be able to get it done, just quickly add those up, subtract from 180, and hope you got alpha and beta correct. Right, so let's do it that way. Adding together alpha and beta. Does anybody have what gamma would come out to? Yep.
117.28.
0.28. Oh, is it? Oh, yeah, 0.280. Okay. Right, any questions on that one? So side, 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 kind of nice because you can pick any version of the formula you want. And you can do each part separate. So it doesn't mean if you make a mistake on one part, you get everything wrong. Okay? And there's only one type. Okay? You're always solving an equation. You're never really doing the type where the variable is already by itself. That's only in side angle side. And the variable is usually right there with side angle side. Okay. Questions on side, side, side? Okay, so last problem. All right, so again, you probably don't need to copy the whole thing, just really the diagram for it would be the most important. But if you want to write down a few important things, you can. So we're measuring the distance between 2 points. And these 2 points are on opposite sides of a house. Right, so maybe you could pretend like there's a river between points A and B. So they can't easily measure across. Or maybe there's a canyon, and they want to know how far it is from one side of the canyon to the other. So what the surveyor is doing is they're looking at the canyon in front of them, or they're looking at whatever's in front of them they want to measure across. And they're standing at point C. Right? Points A and B are in front of them. And what the surveyor does is they shoot their transit laser to point A, then turn it, shoot it to point B, and the transit tells them that it's a 70-degree angle from where they're standing between points A and B. And even though there's a canyon or a river or something in the middle, the surveyor can measure the distance to one of the points and can measure the distance to the other point. Just can't measure between them for some reason. Okay. And the distance from where the surveyor is standing to point A is 50 feet, and the distance from where the surveyor is standing to point B is 70 feet. So we want to find out how far apart the houses are. So A and B are like our two houses. So in our problem, there's house A and B. And the reason I put that we can't measure between the houses is there's poisonous tree frogs. So if you try to measure, you're going to get bitten by poisonous tree frogs. Not good. And then our surveyor, I looked for a surveyor, but I couldn't find one. But I found a German soldier. So pretend like the German soldier is our surveyor. All right. So basically, we've got our triangle. Okay, I'm going to fill in that information between AB and the surveyor. Okay, so that is what we want to know. Okay, call it X. The distance, what does it say? The distance from A to the surveyor is 50 feet. Okay, because it says respectively, so I'm assuming the first one is A, second is B. 50 feet. The distance to B, 70 feet. And last, what does it say? Angle ACB is 70 degrees. Okay. That's a side angle side triangle. Just find the one side you don't know. You don't have to find anything else here. What's angle CAB? I don't know, and I don't care in this problem. What's angle CBA? We don't know, we don't care, we don't need it. So this is where it's helpful to just have the general idea. One side squared equals the sum of the other two. Anyone think they can start to set up that part for me? One side squared equals the sum of the other two. Alex?
C squared plus 50 squared plus 70 squared minus parentheses
Can you tell me, what did we use for a variable here?
C.
So the side we want to know?
Well, of X.
X. So let's do it with X.
Okay. So X squared equals 50 squared plus 70 squared.
Yep.
Parentheses, minus 2 times 50 plus 70.
Times 70.
Yeah,
Yep.
times 70.
So twice the product of the other two. So
Yep.
250, 70. Yep. And the last part?
Cosine 70.
Yep. Cosine of the angle that's across from the side you're trying to find. And now that is more just arithmetic. You're not really solving an equation, except at the end you got to take a square root. But the variable is pretty much already by itself. All right, some of this I think we can do without a calculator. What's 50 squared?
2,500.
2,500. And 70 squared? 4,900. Minus 2 times 50 is 100. What's 100 times 70? 7,000. Maybe a little bit more we can do. What's 2,500 plus 4,900? 7,400. And I think at this point, we need to type that in. All right. Well, actually, one more thing I can do. How would I get x by itself? Before I even simplify the right-hand side, how would you get rid of that square? Yeah.
Square root the other side.
Yeah, it's just square root all of that. So just type that all in at once, then you don't even need to round things off as you're going. Just do the whole thing at once. All right. So, one distance was 50, the other distance was 70. In a triangle, I know if I add two sides together, it has to be bigger than the third. So the distance between the two houses can't be more than 120. If it is, then we did something wrong. Okay. So 7,400 minus 7,000 cosine 70, and again that's degrees, just double check you're still in degrees. And we get 70.76 feet. Anyone else get 70.76? Yep. A couple people got it, some people didn't.
Close.
You got some, what did you get?
Negative 2,308.
I guarantee you there's not negative distance between the houses.
Yeah, I think of the same thing.
So we got to check maybe a parenthesis or something. If you got a weird answer, maybe you want to try it one step at a time. Take the cosine of 70 and just get that first. Then multiply by 7,000 and write that down. But I can come take a look and see what happened. And just to show people how I typed it in, that's how I typed it in.
How are you doing 70.77?
You're rounding wrong.
Yeah, you're rounding.
Oh, I rounded. I'm sorry. It should be 70.75. Yeah. I rounded up when I should have rounded down. Okay, so if you got stuck on it, let me. I'll take a look at your calculator, or maybe you want to use one of mine on the test. It might work a little better. Okay, so homework tonight's on 274, and it's those 6 problems: okay, 9, 11, 13, 17, 25, 27. Okay, so we'll go over that tomorrow. Remember, my extra help is tomorrow, and we'll also review for the test. So no new material tomorrow.